Hello everyone, welcome. So in this video, we are going to work on example problem based on multiplication rule of probability. Here is the example. In a large population, 70% of the people have been vaccinated. So this is one piece of information given. If 3 people are randomly selected, what is the probability that at least one of them have been vaccinated? Give your answer as a decimal rounded to 4 places. So here, what we know is 70% of the people have been vaccinated. That means probability that someone is vaccinated is 0.7. So meaning of that is probability that someone is not vaccinated. Let's write NV for that. Not vaccinated will be 70% vaccinated. That means 30% is not vaccinated. So the probability will be 0.3. So now the question is, if 3 people are randomly selected, what is the probability that at least one of them have been vaccinated? So what I'm going to do is I'm going to create a tree diagram to represent this situation. So when we check the first person, you'll see that the first person may be vaccinated or not vaccinated. If they are vaccinated, the probability is 0.7. And if they are not vaccinated, the probability is 0.3. Now, if the first person selected is vaccinated, the second person may be vaccinated or may not be vaccinated. So vaccinated or not vaccinated. Similarly, if the first person is not vaccinated, the second person may be vaccinated or they are also not vaccinated. So now let's also write the probability for each of these. Probability that someone is vaccinated, 0.7. Probability that they are not vaccinated, 0.3. Probability that someone is vaccinated here, 0.7. Probability that they are not vaccinated is 0.3. So we are looking for the selection of 3 different people. The first one is vaccinated. Second one is vaccinated. The third one may be vaccinated or may not be vaccinated. Similarly, if first person is vaccinated and second is not vaccinated, third one may be vaccinated or not vaccinated. First person selected is not vaccinated. Second is vaccinated, so third may be vaccinated or not vaccinated. And here, first one is not vaccinated. Second is not vaccinated, then third may be vaccinated or not vaccinated. Now let's also write the probabilities on the branch. So for vaccinated, it is 0.7, not vaccinated 0.3. So we continue 0.7, 0.3, 0.7, 0.3, 0.7. That is 0.7, 0.3. So now if we look at the result here, the first one is first person is vaccinated, second is first vaccinated, third is vaccinated. Vaccinated, vaccinated, and vaccinated. If you look at the second possibility, first is vaccinated, second is vaccinated, third is not vaccinated. So vaccinated, vaccinated, not vaccinated. Here, the other possibility is first is vaccinated, second is not vaccinated, third is vaccinated. So we write vaccinated, not vaccinated, and then vaccinated. Here, the next possibility is first one is vaccinated, second is not vaccinated, third is not vaccinated. So it is vaccinated, not vaccinated, not vaccinated. Now, if you go here, you can see the first is not vaccinated, other 2 are vaccinated. So not vaccinated, vaccinated, vaccinated. Next one here, first is vaccinated. First is not vaccinated, second is vaccinated, third is not vaccinated. So not vaccinated, vaccinated, not vaccinated. Next one here. First is not vaccinated, second is not vaccinated, but third is vaccinated. So it is not vaccinated, and vaccinated. And here is the last one. Not vaccinated, not vaccinated, not vaccinated. All three of them are not vaccinated. Not vaccinated, not vaccinated, not vaccinated. Okay, our tree diagram is ready. Now, the question is, when three people are randomly selected, we have to find what is the probability that at least one of them has been vaccinated. When we say at least one, so we need to know the meaning of at least one. At least one means one or more. It can be one or more. So if we look at all these possibilities, see, here none of them are vaccinated, but here you can see one of them. One. Here we have one vaccinated. Here we have more than one because we are looking for one or more, so that is counted. So here one of them is vaccinated. Here also more than one vaccinated because two of them are vaccinated. Here also two of them are vaccinated, which is more than one. And here all of them are vaccinated. That is, all three are vaccinated. So we need all these probabilities, okay, except this one. So what we are doing is we know that the total probability will be one. So from one, we need to subtract this to get the probability that at least one is vaccinated. So we can write like this: probability that at least one vaccinated is equal to 1 minus probability that all of them are not vaccinated. Not vaccinated, not vaccinated, not vaccinated. So which is equal to 1 minus. So here, probability that first one is not vaccinated, the second one is not vaccinated, and third one is not vaccinated, which is this one here. And because we are talking about end, probability that first is not vaccinated, second is not vaccinated, and third is not vaccinated, it is the multiplication rule. So it will be probability that the first one is not vaccinated times probability that the second one is not vaccinated times probability that the third one is not vaccinated. So 1 minus probability that the first one is not vaccinated here is 0.3. Second is not vaccinated here, 0.3. And the third one is not vaccinated, that is also 0.3. So what we get is 1 minus 0.3 times 0.3 times 0.3 is 0.027. Now if we subtract this, it will be 0.9730. So that means probability that at least one of them has been vaccinated when three people are selected at random is 0.9730. So this is the end of this video. Thank you so much for watching. I hope this is helpful.